Hello, my name's Bob Willis and welcome to Winnie TV here at SMT Interconnect. And I have the pleasure of talking to Rolf, and he's going to introduce himself and also his company.
Hello, my name is Rolf Demeitz. I'm Vice President at Viscom in Germany, responsible for the customer care team BO. And we are here at the show with two booths, one at the SMTconnect and one at the PCIM show, because we have customers from the standard SMT business as well as from the specific power electronic business, and therefore two booths are the right decision so far.
Jolly good. I mean, obviously you are known for the electronics assembly market, but now a great lot of interest in the manufacturing of modules. So again, what sort of interest have you seen in systems for controlling processes within module manufacture?
Now, to be honest, the manufacturing is similar to the standard electronic manufacturing with some specific needs for specific inspection, but in general we have solutions for paste inspection, we have solutions for soldering inspection in optical and by X-ray technology. We have solutions for die and wire bond products, and we have solutions even for housing of components, to inspect the housing, to inspect molding, and so on.
Okay, so it's automated, you can do automated inspection of wire bonds, so you can program to look, and to what level? At literally the bond site area, the length of the wire, the curvature of the wire, these types of areas?
I would say we can do everything, of course. So we start checking for the dies on the substrates or on the PCBs to find the position and to check the surface of the dies, to check for contaminations, check for scratches. This can be done before the wire bonding or even after the wire bonding. Then we try to find each bond position, and based on this we know the direction of the wires. And checking the bonds itself means to check for position, to check for the shape, to measure dimensions, to measure the environment, again concerning contaminations or scratches on the pads. And then we can check the wires, to check the course of the wire, to check the loop. And by our 3D technology we can measure the height of the loop, we can measure the height of heavy wire wedges, and of course we also can inspect the ribbons, what is coming up more and more.
What do you think is the challenge to be overcome in the future for this type of packaging technology, or do you think this packaging technology will stay fairly stable for the next 5 years, or is it changing every year?
Well, 10 or 15 years ago, I was told that wire bonding will be dead during the next years, but it isn't.
No.
So the upcoming technology, on one hand, is the sintering of the chips on the substrates, and also sintering of ribbons on the dies. And the other technology is to move from heavy wires to the ribbons for high power applications.
Well, going back to the sort of the SMT, the traditional electronic assembly, what advances are customers asking you for with regard to solder paste inspection or stencil inspection and quality control?
Well, of course, 3D inspection is state of the art, and one benefit could be closed loop technology to inform the printer that there are problems, that there are deviations in the positioning, or that the stencil needs to get cleaned. This is one benefit, and of course on the other hand, the reduction of the height of the paste, the printed paste, down to, in the meantime, 5 to 10 micrometers, soldering paste or sinter paste, and of course this is a challenge.
Based on your experience, sort of, what is the number one problem area that you face on AOI? You know, what is the thing that your systems have been able to provide customers which haven't been previously available?
Now, one challenge is the speed. Another challenge is the resolution of the systems, of course, and some criteria which could not be solved by classical algorithms in the past. And now the integration of artificial intelligence for the inspection, but also to help the manual operator at the verification station will come up more and more, and of course is integrated in our systems as well.
Now obviously you have X-ray capability for through-hole soldering, and obviously automotive manufacturers want 100% fill of plated through holes, and the inspection of solder joints on the bottom side of the board is fairly easy to do. If you're going to implement that. But have customers ask you, or particularly automotive customers ask you, for X-ray capability to look at through-hole fill?
Of course they do. This is, I would say again, this is state of the art. This is very important to have a complete filled barrel, and we had a customer who had problems with voids inside of this barrel, and when heating up the complete board, this barrel explodes, and this is very terrible. So it's absolutely important to have a completely filled barrel without any voids, and you only can check this by X-ray. And typically by 3D X-ray, not only looking from one direction, you will not see all the voids or the missing connection to the via.
And when you say blowing up, what do you actually mean?
The void inside, because of the heat of the complete area, extends and blew up the cap of this barrel, and then
so it broke the via, broke the copper barrel.
Broken soldering, right? Okay,
that's quite unusual. I question the quality of the board to start off with, if that's the case. But it's quite surprising. I have seen it on a couple of occasions, but the board quality was not so good. And the nice thing is, with the high-resolution X-ray, you can then use it to look at the quality of the boards as well, to look at the deviation in the plating and the shape of the plating. Okay. it just seemed kind of strange to me, but I fully understand. So, what is something that is the next thing that people are going to want in terms of module inspection? Is there something else? I mean, you pretty much got it covered. You talked about sintering, traditional soldering, wire bonding, wedge bonding. You talked about ribbon assembly. But you know, what are people asking you for? What's different, and you're probably looking to develop for the future?
Well, in some cases
that you can talk about.
Of course, a little bit. In some cases, it's somehow surface inspection to make sure that the surface is in a correct quality, that all the connections on the surface will stand all the times, the reliability of those products. And for some specific applications, we need the support from artificial intelligence, because you cannot describe exactly in algorithms how to inspect and where are the tolerances, but the artificial intelligence helps us to segment specific areas. And for example, if we are talking about plain soldering, die on substrate and substrate on heatsink, it's easier to segment each void inside of the layers from the soldering, and to see this is the void in the layer between the chip and the substrate, and this is a void in the layer between the substrate and the heatsink. And you can apply different tolerances for this. Yeah, very helpful.
It's going back to the three-dimensional X-ray that we used to have, which then sliced it up, in the old days, sliced it up into individual, put it together, then did the measurements, and now hopefully AI will allow us to automate that process. And of course, everybody wants speed. They want it faster and faster and faster.
Absolutely, yes.
Well, Rolf, it's been a pleasure. Thank you very much for coming along.
Thank you.
I hope you have an enjoyable rest of the show, and hopefully many successes with your customers. Thank you very much.